Bismillahirrahmanirrahim. Assalamu alaikum students. I'm Sabir Hasnan. In this video lecture, we will discuss the further details about the reactions between the acids and metal carbonates. If you remember in the last video lecture, we will discuss some basic concept about the reaction between acid and metal carbonates. Now we will discuss one reaction occurred between the acid and metal carbonates in detail. As you know, this is the third method in which we can produce metal salt or metallic salt with the reaction of acids and metal carbonates now. So there are actually 4 steps through which we can get a salt from the reaction between the lead carbonate and nitric acid. So here we are using the nitric acid. In the first step, look at the figure. In the first step, lead carbonate is added to the nitric acid, and as I told you, whenever the reaction will occur between the lead carbonate and nitric acid, whenever the carbonates and acids react, the carbon dioxide will produce at that time along with water, keep in mind. So this carbon dioxide will bubble, the bubbles of carbon dioxide will produce because it's a gas, and these bubbles will come off from the liquid in upward direction. So this is the first step. So carbon dioxide produced, and second step is put enough lead carbonate. Further, we put enough lead carbonate that must be added to react with all the acid present in that beaker. Put for excess of the lead carbonate, and that's just because all the acid will react with the lead carbonate. And after the reaction, when acid will be neutralized and the excess of lead carbonate will be settled down at the bottom. This is the figure. In this figure we have in the second figure the color of the acid is changed. Initially the color was different in figure 1 in step 1, and in step 2 the color of acid is changed because that acid is neutralized. So, and the excess of lead carbonate, which will not react because that's more than the required amount, so that will not be dissolved into the acid after the neutralization, because there will be no further acid present in that, and the actual chemical will be changed or neutralized. So these are the 2 steps. First step will be the nitric acid is added with the metal carbonate or lead carbonate, and carbon dioxide will produce. And the second step, we will further add the lead carbonate for the reaction. All the acid will be utilized. Now this third step. In the third step, if they, as I told you, they are lead carbonate which is at the bottom, which was not reacted, and after the change of color, so the lead carbonate which was present at the bottom that has not been reacted can be removed by filtering. So here we use the filter. Through filtering we can get out the remaining remaining solution. So the excess lead carbonate which is present at the bottom here, that can be removed through filtering by this filtering process. So that which lead carbonate that has not reacted is removed through the filtering. This is the third step. And in the fourth step, after the filtration, if you remember, there was water was also produced during the reaction. Water is produced in this reaction. So that water can be removed uh, by the evaporation process. So the filtration is carefully heated uh, to evaporate the water. So at the end, a white compound left behind, and that white compound left behind at the bottom is actually the lead nitrate, and that lead nitrate is a, a metallic salt, which is the third method how we can salt is produced. So these are basically the four steps through which we can produce the salts. So keep in mind these four steps. In the fourth step we will filter, and through filter we will heat it, and through heating we evaporate the water, and that evaporate after evaporation we will have the lead nitrate solution, which is a. So now let's discuss the chemical equation for the reaction we discussed earlier. The general equation is whenever the acid react with metal carbonate, it produces metal salt, carbon dioxide and water. And we are discussing the nitric acid, which is HNO3, lead carbonate is PbCO3, and we get as a product we get metal salt, which is lead nitrate, carbon dioxide and water, and lead nitrate is PbNO3 and 2 NO2. There are two further molecules of NO3, and we have carbon dioxide and water at the same time. Water is in liquid state, carbon dioxide is in gas state. AQ stands for aqueous solution, and HNO3, which is aqueous solution of acid, and PbCO3, which is lead carbonate, it is S stands for the solid state. So this is the chemical reaction when HNO3, which is acid, reacts with PbCO3, which is a metallic carbonate or metal carbonate. We will get the lead nitrate and carbon dioxide and H2O, which is water, and the lead is Pb. Keep in mind NO3 stands for the nitrates. Okay, so let's discuss the model of the equation, how through in atomic structure form we can discuss the atoms, and through atoms or we can discuss how the reaction would occur. So look at the figure. Here we have the nitric acid HNO3. H, they are two stands for the two atoms of H. So here we have two atoms of H. At the bottom we have two atoms of H where are separate in red color. And N, they at the center of the three blue balls we have the we have the nitrogen, and on the outside of each nitrogen we have three oxygen atoms, which is in blue. So so it means three blue balls on the most left side are basically gives us three atoms of oxygen, and one ball at the center of these three blue balls is actually the nitrogen, and at the bottom on the most left side are two hydrogen atoms. And after that we have lead carbonate, and lead, this is actually lead, which is in yellow color, and where the three blue balls and one green ball shows this is carbon dioxide, carbon only, and on the outside of on the outside of green ball we have three blue balls. These three blue balls shows us the three atoms of oxygen. So whenever they react, they gives us the lead nitrate. As I told you, look, lead nitrate, lead is on the left side, lead is in yellow color, so definitely on the right side lead is in a yellow color. And NO3, where NO3, here on the left side we have NO3, one red and three blue balls, so two atoms of NO3, which is red one is N, and O3 means 3 blue balls. So there are 2 atoms of NO3. And carbon dioxide, if you remember, on the left side we have at the center of 3 blue balls we have carbon, which is in green. So here we have green carbon on the right side, and 2 blue balls gives us the oxygen as well. And at the end we have water, which is H2O, and you know H2 is hydrogen, 2 atoms of hydrogen. So on the most left side we have, at the bottom we have 2 hydrogen. Those 2 hydrogen atoms are attached with the oxygen,